Welcome back to Quantitative Reasoning. In the previous tutorials, we worked with a data frame that contains information about passengers and crew members on the Titanic. Among other things, we learned how to build subsets of this data frame. For example, we used this command in tutorial 6 to generate a data frame that contained only 40-year-old passengers. In this video, I want to give some background information about what this command exactly does. We learn that Titanic $age equals 40 is an example of a logical vector. We'll find out what a logical vector is and how we can use logical vectors for subsetting. We'll also learn how we can generate logical vectors with comparison operators. Let's go to the Titanic project and start a new script with the menu option File, New File, RScript. Let's call the script explorelogical.r. A logical vector contains only elements that are true or false. We can use the C function to combine multiple logical elements into a vector. For example, Z gets C, true, true, false, false, true. Note that true and false must be spelled with capital letters. In the Environment tab, the data class of Z is abbreviated by logi. We can use a logical vector to build subsets of other vectors that are equally long. For example, let's define a character vector called players that contains Rachel, Tatiana, Noah, Quentin, and Aisha. I'm going to line up the elements in Z and players for later convenience. R is largely insensitive to the exact placement of spaces. Here I'm taking advantage of this feature for demonstration purposes. Let's click Run so that the vector players is in the environment. If we subset the vector players by Z, we get only those indices of players whose value in Z is true. For example, the result contains Rachel because the first element in Z is true. The result also contains Tatiana because the second element in Z is also true. But the result doesn't contain Noah because the third element in Z is false. And so on. At this stage, we might be wondering why subsetting with logical vectors might be anything useful. Couldn't we simply use the method we learned in tutorial 2, namely subset with a numeric vector? In practice, it turns out that subsetting with logical vectors is often easier than determining the numeric indices that we want to keep in the subset. To see why, we first have to learn how we typically generate logical vectors from numeric or character data. Logical vectors are a natural outcome when we make comparisons. Suppose the scores of our 5 players are 5, 6, 1, 6, and 3. R can tell us which of these scores is equal to 6 with the command scores equals 6. The result is a logical vector of the same length as scores, that is, it has 5 elements. We get true at those indices where the score was indeed 6, namely at the 2nd and 4th position. For all other values, we get false. If we now want to know the names of the players with a score of 6, we can simply use the result of score equals 6 to subset the vector player. So the lucky ones were Tatiana and Quentin. The 2 consecutive equal signs are an example of a comparison operator. Another comparison operator is an exclamation mark followed by an equal sign. While the equals operator returns true if and only if both sides of the operator are equal, the exclamation mark equals operator returns true if and only if both sides are not equal. Other inequality operators use the less than symbol or the greater than symbol, possibly in combination with an equal sign. For example, to find the players with a score less than 5, we type players and in square brackets scores less than 5. To find the players with a score less than or equal to 5, we write players and in square brackets scores less than equal 5. Here we use the comparison operators for numeric comparisons. The operators also work with character vectors where they refer to alphabetic order. For example, Gastner is greater than Einstein is of course true, but unfortunately only because G comes later in alphabetic order than E. Let's return to our Titanic.r script. If the Titanic data frame isn't currently in your environment, please run the read.csv command again. The command Titanic, and in square brackets Titanic $age equals 40, comma, is similar to the example we've just seen. The comma in the square brackets makes this expression look a little bit more complicated. But bear in mind that Titanic is a data frame, and for this reason it has rows and columns. In tutorial 6, we learned that the expression before the comma refers to the rows. The blank space after the comma means that we keep all columns. In the highlighted command, we use the comparison operator equals to return a logical vector that is true only if Titanic $age equals 40. As a result, we keep exactly those rows of the data frame Titanic for which the corresponding person was exactly 40 years old. Let's summarize what we've learned in this tutorial. Logical vectors contain elements that can only be either true or false. We can subset a vector by placing a logical vector inside square brackets. Similarly, we can filter out those rows in a data frame that satisfy a certain condition by placing a logical vector inside the square brackets followed by a comma. We can generate a logical vector with the comparison operators equals, exclamation mark equals, less than, greater than, less than equal, and greater than equal. In the next tutorial, we learn more about logical vectors. See you soon.